Hey guys, we're back with the notes for 7.2. These are probably going to be the shortest notes you take for this whole semester. But let's say you get to the end of it and you still don't feel confident about starting the assignment when we get to class. I did link the Algebra 1 notes that go over these exact same topics at this exact same level. So if you feel like you need to see several more examples in order to tackle the problems, please feel free to watch that video even if you're not writing it down, okay? All right. All of the exponent properties are written in this box. Basically, you're following that as if you were going to expand it out and then simplify it. Okay, so I'm going to show you the expanded form in pink, and then I'm going to show you what the shortcut property is in blue. All right, let's go ahead and look at these. I'm going to expand everything out first. Okay, so for this first one in pink, if you were saying p to the third, that's like saying I have p 3 times. And then I'm going to multiply it by p to the fourth. That's saying I have p 4 times. I have a total, all of the same base, but I have a total of 7 of them. P to the 7th. Now, basic rule is here, if the bases are the same, we are just going to add up those exponents, okay? And that rule is written off there to the side, right? Keep the bases, add the exponents. So if you can do that without expanding, then obviously that's going to save us all time. So if I look at problem B, it says r to the 10th times r to the negative 2nd power. I'm going to add those exponents and get r to the 8th. That's it, okay? Most of these don't have work unless there's 2 simplifying steps, max, okay? All right, let's do the same thing for the second one. If I'm dividing problems where the bases are the same, but they have exponents, here's what that looks like. This is like saying I have 9 x's on top and 2 on bottom. Think about it like this way. Every time 1 on top cancels out with 1 on bottom. 1 on top cancels out with 1 on bottom. Now there's none on the bottom, right? All I have left are the 7 that are on the top. In other words, I subtracted the exponents. I did 9 minus 2. Following that rule, if I did the same thing over here, I would say 3 minus 10 gives me a negative 7. And I'll explain what to do with negative exponents in just a second. Okay? Again, steps are written off to the side. Keep the base the same. The base is the number that's holding the exponent, and subtract the exponents. That's your division rule. Okay? All right, problem 3 says power to a power. So you have double exponents, one inside a parentheses, one outside. Here's what you can think about that one. It's like saying I have 3 sets of parentheses, and inside each parenthesis, I have x squared. So I have 2 x's. Total here means I have 6 of them, so x to the 6th. All that we're doing here is we are multiplying our exponents. So if I was going to do that on this problem without expanding it, I would say negative 4 times 2 gives me x to the negative 8th. Okay? All right. Last rule, and we're actually going to hit all of the bottom, and then we're going to circle back, and I'm going to highlight these real quick. We're going to circle back and simplify these one more time. Okay? All right, looking at the bottom. If I was going to explain where this is coming from, I'm going to use a number like 2. We all know that 2 to the 0 is just 1, right? 2 to the first power is 2. 2 squared is 4. 2 to the third is 8. So every time I add 1 to the exponent, I am multiplying by 2. Let's think about going the other way. 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. Whoops, 1/4. 2 to the negative 3 is 1/8. Every time I go the opposite direction, I am therefore dividing by 2. So all that really happened is I got the exact same numbers. All I did was put the number in the bottom of the fraction. That's what a negative exponent does. It changes the location, like the numerator denominator, of the base that you're talking about. Okay? So if I look at problem A is like a whole number. He is over 1. So if I see a negative exponent, that means I want him to move downstairs. I would say 1 over x to the third. When I move him, he's positive now. So when I move him, he's positive now in his new location. Okay? Same thing. If I say 3 to the negative second power, it's like saying 3 over 1. I need him to move downstairs. So 1 over 3 squared. And then we can simplify. 3 to the second power is 9. So 1 over 9. That's the final answer. Okay? Now, the same rule goes if you're on the bottom and you're negative. If I'm on the denominator and I'm negative, that means I want to move upstairs. So we would say x to the 4th power. Now, you don't need to put it over 1. We would just leave it as x to the 4th. You don't have to say over 1 in a final answer. Okay? Now on problem D, again, negative in the denominator means I change its location. I'm going to move him upstairs, so 5 to the 2nd power. You can say over 1 for now. But this one we would simplify. 5 squared, we know that's 25. You don't need the over 1 anymore. Okay? Now, it's possible for you to use 2 of these rules in the same problem, which means that when I said we still need to simplify the x to the negative 7th and x to the negative 8th, because you can't leave an answer with negative exponents, okay? So let's zoom into these. Again, if I think about this as being over 1, I'm going to move him downstairs. So that gives me 1 over x to the positive 7th. This is the final answer. Same thing on the bottom one. This is like over 1, moving him downstairs because he's negative, gives me an answer like 1 over x to the 8th. This is the final answer. So a couple rules to be aware of. Number 1, you cannot leave an answer with a negative exponent. Sometimes it's easier to move the exponents and make them positive first before you start simplifying. So if I wanted to do that on this problem, I could have moved him downstairs and rewrote this problem as r to the 10th over r to the 2nd. And if I had subtracted, because it's division, if I had subtracted it, I would have gotten the exact same answer. 10 minus 2 is an 8. Just like 10 plus a negative 2 is still an 8. It's the same answer either way. It doesn't matter which path you take to get there. Okay? All right, I do want to do one more problem. If you'll slide to the next page, let's do number 9 real quick, because there wasn't really one like this in the notes. Okay, another rule in exponent land is if there are no plus signs, no minus signs, as in this is a monomial. So I'll say that one more time. There are no pluses or minuses. It's a monomial. That means that you can distribute this outside exponent to all of the exponents inside. Now, the y is a base. He has an exponent of 3. The x is a base. He has an exponent of 2. But don't forget the 5. The 5 is a base, and even though he doesn't have an exponent written, it's a 1. So this 3 has to come multiply with him also. Let's look at what that would give us. Multiplying your exponents. That would mean 5 to the 3rd, because 3 times 1. X to the 6th, because 3 times 2. And y to the 9th, because 3 times 3. This rest of the x's and y's are all simplified, but 5 to the 3rd has to go one step further. If you wanted to type it in your calculator, you could do 5 raised to the 3rd power. You could think about it like 5 times 5 times 5, but eventually that's going to be one that you recognize and you know off the top of your head. 5 to the 3rd power is going to be 125, but we're going to keep x to the 6th, y to the 9th as a final answer. This is what I expect to see when you're working through the assignment. I don't need you to declare monomials, and I don't need you to write out how you're getting answers, but this would be the work for a problem. Apply the first step and then simplify, or apply the second step if you needed to. Okay? There should not be a ton of work on these. Most of them will have maximum of 2 steps. Most of them will go straight to an answer. Okay? That is the end of the notes for 7.2. Remember, you do not need to start the assignment until we get to class.